Hey guys, so today I'm going to be giving you a little bit of a step-by-step tutorial for how we're going to be using this Impulse Lab interactive to investigate how force and time influence the overall change and momentum, and therefore the impulse that an object experiences as it is experiencing that change. So what we have, let me pull this back up. So what we have here is you should have picked up this lab packet when you walked in. And so what we have here is, let me see if I can make this a little bit bigger. Um, you're going to be going to this website, and I'll show you how to get there in just a second. You also find that link on Schoology. When an object experiences an impulse, it refers to the effect of a force acting over a time to change the momentum of an object. So impulse is equal to the change in momentum. Now remember, whenever we're talking about changes of momentum, we're really saying that the velocity of an object is changing. And in order for an object to change its velocity or accelerate, it has to experience a net force. So that's how we get this sort of relationship between impulse and momentum. So what you'll be doing is you will be taking a look at how does changing various aspects of how that force is experienced influence the overall momentum change of an object. So in order to do that, we're going to be going to an interactive called Impulse Lab. You can get there by going to Google. You can type physics aviary impulse, or you'll also find the link directly to it on Schoology. But what you'll do is when you get here, you're going to hit begin. And in this interactive, we have an astronaut that's holding a little fire extinguisher. And what we can do is we can actually hit activate. And what ends up happening is that the fire extinguisher pushes gases out. And by Newton's third law, the gases are pushing the fire extinguisher and therefore the astronaut forward. So the things that we can manipulate in this interactive are we can change the overall mass of the astronaut by playing with these little arrows. We can also change the amount of force that that astronaut is experiencing from the fire extinguisher itself. And so it's our goal to try and figure out how does manipulating these variables influence how quickly the astronaut ends up reaching sort of the end line over here. So what we have over here on this side of the screen is we have what are called photo gates. And the idea is that if we know that the distance between these two photo gates is 10 meters, if we can measure how much time he spends in between these two photo gates, we can figure out his velocity in these two photo gates. So that is why if we're looking at this handy dandy thing right here, your lab packet, that's why we have the photo gate distance, we have the time, and you'll end up using those to calculate the velocity of our guy. So what I'm going to do is I'm going to kind of walk through a trial with you and sort of show you how you're going to collect data and thereby also interpret it. So first thing we're going to do is over here, I'm going to set my force initially to 115 because that's what it says on the packet. And I'm actually going to go all the way down to 35. I'm going to use the lowest mass because the very first thing we're testing is how does changing mass influence the motion of our astronaut. Now, before we begin, I'm going to recommend that you come over here and you click in this time area. And so what it's going to do is actually going to change it from milliseconds to seconds. And this is actually what we want it to be. We want it to be in seconds. So what we're going to do is we're going to hit activate and we're going to let our astronaut accelerate all the way to here to the photo gate, but we're going to make sure that we hit shut off. We're going to stop hit right when he gets to the photo gate. That way we can make sure that he's traveling at a constant velocity in between these 2 points and not still accelerating. So I'm going to hit activate. We're going to watch Wally take off. He's doing his thing. And as soon as he gets to that first photo gate, I'm going to turn it off. And then we're going to record these data points. So the data points I'm going to record that his mass was 35. I'm going to record the time that it took him to travel through the photo gates. And I'm going to record the amount of time that the force is being applied. So I'm going to come back here. I'm going to zoom in just a skosh. Shoop. I'll zoom in right here. So my photo gate time was 0.509. My mass of Wally for this trial was 35. And the amount of time that the force was being applied, or the amount of time that the fire extinguisher was on, was 5.981 seconds. So here's what we're going to do. I'm going to take this information and I'm going to say, we're going to figure out his velocity that he ended up achieving. So the velocity that Wally ended up having, we're going to say he traveled 10 meters in 0.509 seconds. And so if we pull up a handy dandy little calculator, we'll get there somehow. Calculator. If we do 10 divided by 0.509, enter, we get that his velocity was 19.6, I'm just going to round it to 2 decimals, 65 meters per second. So now that we have his mass and his velocity, we can use those numbers. We can use his mass and his velocity, mass, velocity, and we can use that to calculate his momentum. So his mass was 35. His velocity was 19.65. So I'm just going to go ahead. 35 times 19.65. I think it's 687.75. So now let's compare, how does that overall momentum change? How is that? And you should find that your overall calculated momentum change here should be really, really similar, if not the same, as your calculated impulse here. So let's go ahead and do that. Let's just do that calculation as well. So what we're going to do is we're going to take this force and this time. We're going to multiply them. Should we say 115? So this is the amount of force that was applied to Wally, our astronaut. And this is the amount of time that it took Wally to accelerate, or the amount of time that he experienced that force. And so if we do 115 times, what is it? 5.981, enter. We end up getting very close, if not the same amount. And the only reason why it's probably off a little bit is because we rounded our velocity before. But we should see that overall, our change in momentum is pretty much the same as our impulse that is experienced, because impulse, by definition, is the force that causes changes in momentum. So what you're going to be responsible for doing is trying to repeat this, but doing so at various other masses. And then what we'll do, and you'll calculate, how does changing mass influence that overall change in momentum? And then from there, you'll sort of talk about, how did changing mass influence how quickly he accelerated to the photo gate? So that's the first experiment. The next experiment, you're going to do the exact same thing, except you're going to be changing the force. Now, just as a reminder, you can, for those trials, you're going to end up setting his mass to a constant value. Make sure you check the data table, but you can adjust the force all the way down to 50, and you can pick whatever trials you want going all the way up to 200. So I hope this helps. Good luck. And if you have any questions, you can shoot me questions on Schoology, but I'm very confident that you guys can handle this on your own. Thanks.